Today we're going to look at how to solve systems of equations by substitution. Now, the way that you solve systems of equations by substitution, you can do it algebraically, but today we're going to look at it through a little visual model. So look at these two equations, y equals 6x plus y equals -1, and y equals -3x minus 4. If we think of each of them as a box, that inside the y box is a -3x plus minus 4, we're literally taking negative 3x's and -4 and putting it inside the y box. So inside of our box, you can see I put 3 x's that are negative and a -4. Just keep that in mind for a second. Now let's look at this -1. Inside the -1 box, there are 6 x's, which I just put in there, and also a y. However, we just figured out a second ago that inside the y box, there are -3 x's and there's a -4. Therefore, since this is the same system of equations, and remember, in systems of equations, the two equations work within the same system, so the x's and the y's are always equal. Therefore, in this equation on the right, we can actually put in what we know about y already. We already know that y has -3 x's and a -4. And then we can actually just get rid of y altogether, because now we know that what y equals is -3 x's and a -4. So we can just get rid of y. And all we have left is this the positive 6x, and then we have -3x. And since they are all x's together, we can combine them together, and x minus x is 0. So all of those x's inside the red box would actually just cancel out, because x minus x is 0. Or if you just want to think about it more simply, 6 minus 3 is 3. So we have 3x minus 4. And this is, remember, all of it is inside this -1 box, because originally we said that -1 equals all these things inside the box. So we can now do this kind of algebraically. We have the -1 and we have the 3x minus 4. And the first thing that you would do algebraically is try to get the x by itself. We need to get rid of that -4. And in order to do that, we can use the reciprocal, or the opposite number. The opposite of -4 is +4. And since we're using a positive number to add, you need to remember that positive moves numbers right. So we're starting at -4, moving 4 to the right. And when you move 4 to the right, it ends up with 0. And 0, of course, in an algebraic equation, you can kind of just cross out, because 0 doesn't change anything about the final answer. We can bring down the -3x, and then we could bring down whatever it is when we have -1 plus 4. Again, I have a dot on the -1, and because it's plus 4, positive, we're going to move it 4 to the right. And when you move it 4 to the right, 3x equals 3. And so we can kind of just get rid of everything else now that we have a much simpler problem. And all we have to do now is figure out how many, if we were to divide 3x up so that we have each x by itself, and we were to divide them up like this, we would have to divide it into 3 boxes. So if we were to divide 3 into 3 boxes, so to speak, there would be 1 in each, because 1, 2, 3. You could also do the old algebraic way, where you divide by 3 on both sides, and your final answer is x equals 1, because 3 divided by 3 is 1. That helps us solve for the x. Now all we have to do is go back to the original problem and use one of these equations to figure out what y is. I'm going to use the second one because it's a little bit easier in my opinion. And all we have to do is take the x equals 1, and since we know that x equals 1, we can plug it in to the equation. Literally just put it in there. So take out the x and put in 1. Remember that when 3x is right next to each other, that means 3 multiplied by x. So now we're going to do -3 times 1. And -3 times 1, any number times 1 is itself, so y is going to equal -3 minus 4. But remember, when it's minus 4, the -4 is going to move that -3 to the left, because a negative number moves it on the number line to the left. So we have to move it 4 points to the left. So if we do that, it's going to go 1, 2, 3, 4 down to -7. So y equals -7. So for your final answer, you would have x equals 1 and y equals -7, or 1, -7. And that's kind of a visual way to solve systems of equations by substitution.